Good morning, one and all. So, in this lecture video, we are going to see about multiprocessor scheduling. So, first of all, we can see the definition, right? What is multiprocessor scheduling or multiprocessor scheduling? The other name of multiprocessor scheduling is multiple process scheduling, which actually focus on designing systems scheduling function which consist of more than one processor. We have already seen the difference between single processor system and multiple or multiprocessor system in the previous videos, and we saw the drawbacks and advantage of both the systems. Why we need multiprocessor scheduling is the main concept here is load sharing. Simply all processes, instead of dumping into one single processor, rather we could use this multiprocessor scheduling so that all the process can run simultaneously. But the drawback is it's actually a complex structure as compared to single processing scheduling. What the problem arises here is called as synchronization. And the multiple CPUs in the system are in close communication, which can easily share common bus or memory and other peripheral devices. So we can say the multiple processor communication is, system is tightly coupled. When we trying to process bulk amount of data, we need the help of this multiprocessor scheduling, which is mainly used in satellite and weather forecasting, etc. So what are all the approaches to multiple processor scheduling? We have symmetric multiprocessing and asymmetric multiprocessing. We will see one by one. What is symmetric multiprocessing is? By the name itself, I can say it's actually a self-scheduling multiprocessing. All processors may be in a common ready queue, or each processor may have its private queue for ready process. And what is asymmetric multiprocessing is? It is used when all the scheduling decisions and input-output processing are handled by the single processor called the master server. Here it will act as client or server problem. This is simple and reduces the need for data sharing, and this entire scenario is asymmetric multiprocessing. And what is the name called as processor affinity? Processor affinity means a process has a liking, or we can say it as wish, for the processor on which it is currently running. So when a process runs on a specific processor, there are certain effects on the cache memory. What effect we will be seeing in the following slides. So the data which is most recently accessed by the process, it has to populate it into the cache memory. So what will happen when successive memory accessed by the same process, it is often satisfied in the particular cache memory. Here the problem occurs is, if all the processes use the same cache memory, there is no problem. If a process wish or having the affinity to move from one processor to another processor, there arises a problem. What the problem arises here is, we need to invalidate the first processor, and we need to revalidate in the second one, and we need to change the cache content as well, which is not the easy task. There are two types of processor affinity. One is soft affinity and hard affinity. What is soft affinity is when an operating system which has a policy of keeping a process running on the same processor, which is called as software affinity. The opposite thing is called as hard affinity, where we will try to migrate from one processor to another processor. And next topic is called as load balancing. We already discussed why we are going for multiprocessor scheduling and what is the purpose of load balancing here. So okay, once we have moved to multiprocessor scheduling, we have to we have to split the load into all the processor. Rather, we should not act exactly as single processor. So only it is necessary only on systems where each processor has its own private queue of a process which is eligible to execute. If you take symmetric multiprocessing, it is very important to keep the workload balanced among all processors to utilize the benefits of having more than one processor fully. And here also we have two approaches. One is push migration and another one is pull migration. What does push migration is? Push migration, which is actually a task which is routinely checks the load on each processor. It finds if it is an imbalanced one, it evenly distributes the load on each processor by moving the processes from overloaded to idle. Pull migration occurs when an idle processor pulls a waiting task from a busy processor for its execution, which is opposite to push migration.